exactly the same solution. How big is the tree? 54 feet tall. So how did you solve this one? Just out of curiosity, how did you solve this one?
6 times 72.
You did the 6 times 72? Is 8 times a t? Okay? And then you can actually divide, at this point you can divide off the 8s. 8 divides into 72 9 times.
How about you can just cross multiply? 6 divided by 6 times 72 and then instantly divide it by 8 and just get the answer.
What, say that again?
Can't you just go 6 times
what I'm doing.
72 divided by 8? Oh, you just did 8 times t, it just didn't make sense.
Well, if you cross multiply, t's in there.
Well, yeah.
Be consistent,
I was going like
come on now.
the little.
Let's not be cherry picking. I like Pringles, not Ruffles. You gotta eat Pringles with Ruffles.
I don't do this, for sure.
Does everybody see what I'm doing here? As far as actually the units are gonna cancel each other out because they cancel. So you got 6 times 54 feet is how big your t is, which is gonna be the exact same solution you get at the bottom. Notice the cross multiplication. If you do a cross multiplying, it seems like you guys are big fans of that. Totally awesome. If you cross multiply this or this, that equation looks the same. 6 times 72, 6 times 72. It's one of the cool things about proportions. You can set it up any way you want to. If you solve Lego, if you solve cross multiply, it doesn't matter to me. What's that?
As long as they're equal to the right.
That's the kicker, is you got to make sure you keep the proportionality. If you pick a side in this triangle and compare it to another side in that same triangle, you got to make sure you do it the same way in this triangle. Conversely, you could also pick a side in this triangle and compare it to its corresponding side in the other, and then go back and do the same thing in this triangle. Does it make sense? Mm-hmm. And it's that is similar triangles, pretty much all of it. That is pretty much all of it. But the power of it is, this can be humongous, and you can get values for this stuff without ever getting close to it necessarily. That's what your exam question does. Your exam question is going to do stuff similar to what we're doing in class today, except I'm not going to let you go to the base of the tree and measure from that out. That's what we'll do in class today. So anyway, I'm getting ahead of myself. We'll go talk about that. The third case, the thumb case, we'll deal with that on the field together. Okay? So what I got here, everybody grab one of these. It's basically a worksheet. It's a scratch sheet for you guys. On case number one, I called the shadow case. I drew a picture of 2 blank shadow triangles there for you. Case number 2 is the mirror case. I drew a image of 2 mirrored triangles there for you. And the third case is the thumb case, which we didn't get to yet. We'll get to that today on the field. So everybody know where Mazama Field is? You know where the library is? There's a track next to the library.
Does everybody need one?
That field. Go there. Meet you there like 5.
Does everybody need one? Or?
Yeah, everybody take one, because this is good. You're going to put your notes on here. I'll have to find a chalkboard once we get down there. I'm thinking the parking lot would be nice. Okay, doke? Oh, you got it. Well, it's okay. It's good day.
I just don't want this to affect on if it's already been turned in.
We'll just turn it in.
But if it's already been turned in and graded.
It hasn't been graded. That's the thing. And that's why if it's not in this pile, chances are you didn't turn it in. It just means that you thought you did, but you didn't. Now you did.
Well, I could have sworn I turned it in either Monday or last week.
If you did,